Hello, fellow Econauts, and welcome to our show where we talk about science, space, and economy. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you doing?
Hey, how's it going? Hi, Econauts. Hi, Simon. Hey, Simon, what's the topic today?
Our topic today is space weather, and I would like to know what is space weather?
Well, space weather is similar to what we experience here on Earth. It's caused by the sun, but it's all the conditions around the Earth and around, like, let's say, anything between sun and Earth, which can affect our technology and our buildings and stuff on Earth.
You mentioned that it's based on the sun. I I think it's also affecting our technology in orbit, not only on the planet, right?
Yes, that's correct. Anything which is close to Earth or on Earth.
All right. So that means that next time we send astronauts to the ISS, we should give them some umbrellas
Yeah.
in case it's raining.
Well, I mean, the funny part of this is obviously, as I mentioned, on Earth the weather is also caused by the sun. So even wind is, at some spots there's a bit more heat than others, and this starts a circulation of air. And you know what? You can have a sail in space as well, a so-called solar sail, and it's actually a very thin, micro thin foil which collects photons on one side, and that can push a spacecraft. So, funny you say that, but actually we have some wind in space as well.
Yeah, we have wind, but no rain,
Yeah,
right? I
no,
mean,
we have no rain,
that's
of course not.
of course not okay.
Yeah, no.
So we already started
Maybe some
talking
meteor
about,
showers.
well, hopefully not. But we already talked about that. Now we start talking about that. So how does it affect us in on the daily basis?
Let's go one step back. What kind, let's say, let's give an example of what kind of effects the sun can have in outer space. So the sun obviously is a it's not a solid thing. It's has reactions, and the fusion is happening all the time, and there's lots of chemical reactions and physical reactions going on, and that causes a number of things the sun can actually do. And one thing is solar flares. That is a sun intense burst of radiation from the sun surface, accompanied by X-rays and ultraviolet radiation. Then we can have solar winds. So there's a continuous stream of charged particles, mainly electrons and protons, flowing from the sun into space. We have so-called coronal mass ejections. So these, the sun's corona, there's a massive explosion disrupting, causing geomagnetic storms on Earth. And these geomagnetic storms also are disturbances which can travel from the sun to us. And maybe just keeping one step afar from Earth is obviously the moon, and we have mentioned that in the past. The solar winds, for example, are the reason why we have helium-3 on the moon's surface. We don't have helium-3 on the Earth's surface that much because we have a magnetic field around the Earth, and that magnetic field is actually protecting us from many of those effects on Earth.
So you mentioned like the solar flares affecting our weather in a way, and I can assume also our electronics in space, right?
Yes,
So
yes, yes. Yeah.
I know that you mentioned that before the show that those solar flares can affect the equipment that we have in space. Maybe you can talk a little bit about that.
Yeah, of course. So, coming to the satellite operations, the geomagnetic storms caused by those effects from the sun, they obviously can interfere with electronics. So, if you have a magnetic field, electromagnetic field traveling through or over an electric device, it can cause electrical shortens in or short circuits in the electric device, and that can burn resistors and so on, and can destroy a an electric device. And obviously, satellites are electric devices, so they have to be shielded. So yeah, and GPS, the GPS satellites, for example, they are very important to us. And if you use Google Maps, for example, again, we are not sponsored by Google, so never, I'm not advertising anything here. But yeah, if these satellites are affected or even destroyed by those geomagnetic storms, then we would be in big trouble. And that's why we have to monitor. So there are agencies such as NASA and others who are observing and predicting those weather effects from the sun.
To connect to our previous show about Starlink, uh, it is basically if the solar flares are affecting those satellites, that means that the internet connection can break down. Is
Yes,
that correct?
absolutely. Well, and if you imagine the worst case, you can completely lose a satellite, which then would drop out of its orbit. In case of LEO, low Earth orbit satellites, they might just enter the atmosphere and then burn so
Mm,
prematurely. And then obviously you lose one. And if you lose, and so Starlink, as we explained the other time, is a satellite constellation, so built up of many, many satellites. And if you lose a number of them, you might have a big problem. So
right, right.
yeah,
But how likely is it that you lose? I mean, we talked about that in an earlier show that SpaceX is planning to have like
yeah.
40,000
So they,
satellites in
yeah,
orbit
they
at some point.
yeah, they need 12,000, or that's the plan
Yeah,
at least, and they would like to extend, or there are plans to extend that to 44,000. Let's say 40,000. I think that's a high number anyway.
that's a high
Nobody
number
would.
anyway.
Oh, is it no 40,000 or 44? I can't count. So it's like,
Yeah, well, but how likely is it that if there are so many that a solar flare can affect like the grid so immensely that like internet connection it's like broken. I think that if and I might be wrong, but I think if a solar flare is hitting like one or two, well, okay, that's maybe like not the best thing and need to be replaced, but it's not affecting like the entire internet. If you connect to the
that's
internet
correct.
via
Yeah,
Starlink.
yeah. That's very correct.
But is
Yeah,
that's very correct?
yeah.
Okay, so it's not like affecting. So if there's a solar flare, because they're also like we are talking about, they're not like cozy, cuddling together. Those
No,
satellites,
no,
they
no.
are like very far apart, right? And they're basically like if they're affected one or two, it's like not a big deal,
No, no,
right?
no. It depends, obviously, how many of those satellites in the constellation are already there. So if you imagine, let's say you have a constellation made up of 10 satellites, and you lose one, that's a 10% loss of the constellation. If you have 12,000 satellites when the constellation is at its planned state, and you lose one, there's almost no difference really, and
Yes.
it's a dynamic network. So the satellites, they are all interconnected with each other, and the signal, if speak from a consumer or from a user, is using the best pathway. So if you lose one, it doesn't matter. Also, um, by regulation, LEO satellites have to deorbit after 5 years for that reason as well, because they will deteriorate over time because of effects they are experiencing in LEO. And therefore, at some point, they have to deorbit as well. There's one important fact, though. LEO is still within the electromagnetic field. So the likelihood of solar effects or sun effects in any satellite in LEO is less likely because the satellites are protected by our magnetic field as well.
Because they were smart enough to bring an umbrella.
Exactly, the umbrella is our magnetic field. And
Yeah, the umbrella.
the interesting thing, maybe just on a side note, the magnetic field of the Earth looks a bit like an apple. So if you imagine North and South Pole, this is where you have
Yeah,
the nubs, from the apple, and then it surrounds it, which also means if you fly along the equator, you are more or less always within the magnetic field as long as you're within a certain distance. if you fly over the poles, you leave the magnetic field
Yeah.
once in a while, like twice every turn. And these uh, yeah, this shape is also responsible for the auroras we have, the polar lights we see at the south and the north pole, because that's where
Right.
the magnetic field then interferes with the radiation of the sun.
We already started talking about the importance of space weather. Maybe we can talk a little bit about you mentioned the helium-3. Um, so we so basically if we have on the moon a spaceport. um, there you get the
Yeah,
spaceport. If
that
we
would
have
be
on
the
the
running
moon
gag.
a spaceport, we are not going away from the spaceport. This will be a running gag for the rest of our show. Um, if we have a spaceport on the moon, we can harvest helium-3, right?
Yeah.
At some point, obviously. And because of the weather, we will have like almost unlimited amount available, right? We basically
Yes.
can harvest that for
Yeah,
eternity.
you could. I mean, obviously, we haven't really tested yet how much we can get out per square meter or cubic meter of regolith. Regolith
Sure.
is the soil on the moon, um, and we can make calculations and we can predict how much helium-3 we should find per square meter on the moon. But to really know, we have to extract and then go to the same place again after a certain time, and then extract again, and then this way we will figure out how much gets replenished. But I think it's quite safe to say that you can look at helium-3 on the on the moon surface, as a renewable source of material. And if we figure out how to do and how to extract the potential energy of it through fusion, then you could also say it's kind of a renewable energy to
Right,
go
right.
this
And
way.
then we can have like fusion reactors that are giving us like the electricity that we need. And then we basically don't have to
Yeah.
burn gas and oil
Yes.
for electricity, right? Which is like an interesting source to be honest. And
Yeah.
it's
Yeah.
also, I think that you mentioned that last time as well, or in one of the previous episodes as well, that we can also use that obviously to have like electricity on the moon,
Well,
right?
of course, but I think on the moon it wouldn't really make sense to build a fusion reactor, because it's already very complicated to do this on Earth. We haven't even figured out to have a continuous fusion reactor yet. On the
No,
moon,
I'm sorry, but I'm what I meant was like if we have like a base on the moon, if we have like actually a base on the moon, at some point we may want to have like electricity
yeah,
there
of
too,
course, but that, yeah,
to have
yeah.
like oxygen for I think that people need
Yeah,
oxygen to
for that,
survive.
yeah, but for that you need water. So for that you're figuring out where's water,
Right.
and then you need solar panels, which you need then to run or to generate electricity to split the water into oxygen and hydrogen. So the electricity in space itself comes from solar panels.
So we would not at all think about that, even if we have like a little city on the moon.
Well,
I'm
yeah,
just worried
at
way
some point,
way in the
yeah.
future.
Yeah, at some point, surely, but solar panels in space usually are way better than solar panels on Earth. So they have a higher um, efficiency. So on Earth, you get like
Yes.
16 to 20% ish, whereas in space, the solar panel itself has an up to 80% efficiency. And also the on Earth you have the atmosphere, so therefore most of the light is getting absorbed. You have weather effects and so on, which you don't have in space and on the moon. So therefore, it makes totally more sense to.
Wait. You just talked about we're just talking about space weather. So
Yeah, but the sun.
how can you say that it's not affecting
Well,
talking about space weather here?
we have no clouds on the moon, right?
Yeah,
So
I
yeah,
know what you mean. All right. Well, that's it for today. Thank you so much for your time. Was a nice talk
yeah.
again.
Thanks.
Um, I really hope that you enjoyed the show. If you do, please don't forget to leave a like, subscribe to our channel if you haven't already, and I would like to hear from you in the comments. So thank you very much for tuning in, and have a nice day.
Have a
Bye
nice
bye.
day.